Hello 108 students, Mr. McHugh here with you. Welcome you to 3.5, page 5 of our class notes. And big thing I want to mention here, this corresponds with 3.6 in our current textbook, and I am going to go ahead and cover these things. What happened was just this is the way it went from version 10 to version 11, and I'm glad the textbook did this. This was just an objective in section 3.5. It's now a whole entire section out of the book. They expanded it a little bit, and it's good because the concept of a function is critical to understand in your algebra skills here. Again, it's this idea I've talked about at the beginning here of a function is like a task being done, and I have this again. I'll go through this quickly, but think of a toaster as a function. You have the input, the number of slices of bread that you put in. If you put 4 slices of bread and they go into the process, they get heated out, what will come out, class? It's 4 slices of, big thing is what? It's toast. Okay, some of you guys like it extra dark, some of you like it light. You control it here on the toaster, and that's what we got going here with linear equations. Okay, so I'm drilling this in your head, but the x value is your input. It goes into the process. Think of this as the calculation. Okay, so if I tell you x is 4, you put it in. 2 times 4 plus 1, what will that be, the output? 2 times 4 is 8 plus 1, the output is 9. Okay, so what's happening here is what I've written here. I would start off and say 2x plus 1 equals y. That's what my expanded xy table that I've been showing you guys, and I like to put think of the x comes into the process, you calculate it, and it generates the output. Okay, now what happens here is mathematicians, and most of us are comfortable with, we like to switch the whole entire left side and right side. I wish you could see my hands, I'm taking them. You're allowed to switch because they're equal, right? The left side and the right side can be swapped, so do that. Imagine if you're on a seesaw and you had 2 friends and you were able to maintain balance. You both weigh exactly the same, and you got tired being on the left side. You swapped with the person, you got back on, you still would have the seesaw in the middle. So we're going to write y equals 2x plus 1. Okay, now what's this section about? This section is going to deal with notation, functional notation. And the idea here is, you know that for every specific input value of x, you get one and only one output value. Mathematicians wanted to have a tool to allow them to represent those specific moments of ordered pairs on your line. And so instead of saying y, they are going to use this notation called little f, and think of little f for function. I was so glad when they did that. Little f parentheses x equals 2x plus 1. Now what's going on here? Instead of saying y, we now are going to have the equivalency. Don't freak out about this. F of x is the same as y. Okay, but what that does for you now is it does not mean multiplication, it means f of. What value of x, this is the generic form, any value of x, if you put it into the function, the process, you will get an output. Okay, it does not mean multiplication, so that's the first thing you got to remember. Now I know you see parentheses, you've been trained to say multiplication, but this means f of. Okay, so you can see here, I'm writing here on the side, we've got that going. How do you use this? How do you handle the power of this function? Why use this? It allows you to pick a specific input value for x and determine its matching output value. This is why we're doing this notation. So let me show you an example here. They will tell you, they will give you this generic function, and they turn around and they'll say, what is f, and they'll put a number in here. I'll pick with what I got down here. F of 3 equals what? And you're like, huh? What am I supposed to do? They're telling you x now has a value of 3. You go back into the linear equation, to process the calculation, and instead of putting x, you're going to put the 3. You substitute it in, and you evaluate it. 2 plus 3 is 6 plus 1 is 7. So f of 3 is 7. Now let me scroll down here just a little bit. What are we representing here? Look at my graph down here in the bottom here. 3 comma 7. Now this is the same problem. F of x equals 2x plus 1. I turned around, and when x was 3, I come up, I hit the graph, I come across. What is the output? The y is 7. We've just proven that to ourselves, and the ordered pair 3 comma 7 satisfies that equation. Okay, now let me prove that to you here again. So we're saying 7 is the y, so I'm doing y equals 2x plus 1. I'm putting 7 in for y. X has got the corresponding 3. That was the input. I chose 3 for x. 2 times 3 is x plus 1. Does 7 equal 7? Yes, of course it does. So every ordered pair that you find on a linear equation is a function, and it makes the equation true, meaning the left side will equal the right side when you put the values of x and y coordinates into the equation. Okay, now I know this is fairly simple, but this is powerful stuff. We're going to be using this throughout this semester and going into 143. So here's another example problem here. If I ask you to take the y equals 2x plus 1, or f of x equals 2x plus 1, remember, you can say y if you want, but f of x allows you some flexibility of determining specific values. If somebody asks you what will be the output when x equals 5, you turn around and you go 2 times 5 is 10 plus 1 is 11, and you've done the problem. Okay, I think I've done this page here, so I'm going to go on to page 6. I think I'm pretty happy with concept being covered. So you now know a function. Oh, by the way, we use f of x usually. That's little f of x. No problem if they use a little g of x. Don't let that freak you out. They still is a way to represent two functions being talked about in the same problem. Sorry, sometimes I wiggle my hand too much. I apologize about that if I make you dizzy. Okay, hey, Mr. McHugh, I'm going to sign off here for now. I'll be back for page 6 as we continue 3.6 on functions. Okay, bye.